here I'm sharing some tips for C++ development, which I could find you may also encounter while you use C++ for any kind of development, mostly related to industry grade programming. So I'm just expressing my personal ideas and views. First thing that I have encountered a lot is that we should use meaningful names. That the identifiers are not just uh, names to identify entities, but they should also be a kind of description to what functionality that identifier actually provides. Because many of times that we see is that there is a lot of code that we go through, and we need to quickly uh, go through or identify the code that will be relevant to our task, right? So we are looking for some kind of function like uh, which which computes grades, right? And you encounter a function which says grade. Now this is a bit confusing, like whether does it print the grade or whether does it compute the grades. So, and many of the code reviewers who will review your code or use your code will just ignore this, right? If they are interested in the function that compute the grade. So instead you can use a simpler, like a better name with a bit more descriptive, not should not keep it very lengthy, otherwise it will be difficult for the readers to understand it again. So what I found that functions mainly provide some kind of functionality. So just append the part it is working on and the functionality, like your grade and then the compute. That's it. One more example that I have, like we have this type of code on the left side. Uh, just int wheels has been used as the property seats. So what does it mean? Like, does it describe the seats or does it describe the number of seats? And V type, that is even worse. What is V? It is difficult to understand. Right? So just expand it in a bit more way by adding some comments. Because it may happen that you are just writing a class and then it gets reused by multiple other developers. And uh, it is like my personal opinion, like when you'll see a code on the right side, you will want to explore or more on this. But if you see a code on the left side, you'll just want to ignore it. The developer himself has not put in a lot of effort here to explain what he's writing. So that is one of the tips here. Adding comments is never a bad idea, but the variable names are the first thing that will be the kind of representation. Second tip is to use null PTR instead of null. So null we used to use mostly in C, but in C++, a new keyword has been added, which represents any kind of pointer. And it has a separate class also for itself, right? So the question is like why we are using null PTR. So the reason is that null is just a macro for 0, and the compiler, you will always know this, will just replace it by 0, and then it can be interpreted as the integer 0. So in this case, if you can see, f is a function here which has uh, two different signatures here, right? So first is just a pointer, using a pointer, and the second one is using integer. So if you will just pass in null, the implication is that like, that looks to be like the developer wants to call the first function because he has used null, uh, but actually it will be calling the second function, and it gives rise to a lot of function. And yeah. Yeah, so these things, like while debugging things, many of the times that happens is that you will miss out on very small items, and that will be taking up a lot of your time, right? So I am just bringing out some of the things, some small nitty-gritty things here and there, which will avoid that kind of time taking. So this may be confusing. So another tip that I have is use uniform initialization. So what is uniform initialization? So first thing is that Uniform initialization provides a way or a similar syntax to initialize variables of type primitive or aggregate or component, right? So on the left side, if you see the same syntax is being used to initialize built-in type, an integer uh, with a 0 value, with a 10 value of int as well. Then the same syntax, almost same syntax has been used to initialize an array. Then the same syntax has been used to initialize the class object, right? And same syntax is being used to the copy uh, constructor, right? So this is what about is uniform initialization, and I'll come to like why to use it. And one question that may come up is like, suppose you have a code on the right side, is a car class, and you have multiple parameters that are being passed to the constructor of it. So you can just pass in via the curly braces. It will not be a problem. It is the same as using the uh, parenthesis, which we generally use to invoke this constructor. So that is one thing that I wanted to draw. So like this is like a very powerful tool. This is, I think this was introduced in C++14, but I'm not really sure. So yeah, to get rid of parentheses wherever possible during initialization. And this is not for copying, okay? This is just for initialization, like straight away you are initializing. So what are the advantages that we get from this? It forces value initialization. That is the first thing. You will just generally what happens I've seen is that we write int and I, suppose the variable name is I, and we are in a habit to just initialize it later on, right? And with C++, there can be some kind of garbage value, and then things can get messy there if you forgot to initialize it later on. So why not just add a kind of parenthesis there, right? And this can also work with structs and all everything. Just add a parenthesis there, and it is like a very fast, like it will not take much of your time, and it will be just initialized there. So, and you will be also have being of a habit to initialize variables as you declare them. That is the first advantage. Second thing is that one thing of C++ is that you can assign floats to integer variables as well. So that is not actually allowed while using uniform initialization. It will just error out, or it will warn that you are initializing a float variable uh, to an integer variable. And there is one more case, another like this can also like take up a lot of time for you to debug this. So this is a bit tricky, like vexing parts if you've heard of. So vexing parts is like something in which the compiler confuses object initialization with a function prototype, right? So if you have two classes here, R and car here, and car takes R as an argument in its constructor, and in int main, what we do is that we create a new uh, car object named C, and since the constructor uses object of type R, we just call its constructor, so that will be returning us some object. And this is looking very straightforward, right? This is just creating an object of car, which is named as C. But actually what is going to happen is that the compiler is going to misinterpret this as a function prototype, which is named, the function name is C, and it is returning an object of type car, and which takes in a parameter of type R. And this is also valid, right? This looks to be of a function prototype, and this can happen to you. It will throw out some error, or it will also just execute without creating the object C. So what we do with uniform initialization is just use curly braces instead of parentheses for initialization, and that solves us the problem. There is no confusion that the compiler. Everything works fine. Okay. So one more thing that I have for you is to use if and switch with initialization, and this was introduced in C++ 17. And what this helps is to reduce the scope pollution, right? So if you look at the syntax, there is an initialization clause and then there is some kind of condition clause. So condition clause, we already know it is used to check whether the compiler should execute the body of the if or switch statement. Sorry, not for switch actually, for if, and select. So for switch is just used to uh, identify the identifier which it should use inside the switch statement. So there is an option that you can just add an initialization clause with a semicolon, and then the scope pollution will be reduced. For example, on the right side, if you see, if you want to create a void pointer p and use and just get some kind of uh, malloc defined space there, and it may happen that the space returned by the function is null. May have it may not be assigned to us. So that then the variable p remains in the scope, right? If we move this outside the if statement, and then we are just checking whether p is null pointer or not. So that is, I'm just saying like what is the usual uh, mechanism that we follow, is moving this code outside and then just checking. But p still remains in the scope, right? Then this can cause some kind of pollution where the other variables are also able to access p, and it is like not very clear. So why not just initialize it inside the if statement, and then you will be able to use inside if else later. So it is like not that if we will use p here in the if initialization clause, it will not be available in the else, it will be available in the tip. So another tip that you may also know is used to use static computation and not rely on the uh, runtime, because that may be that can throw some kind of exception. You can face a lot of it. So whatever possible, try to compute at the compile time itself, and this also improves the runtime of the application. Very straightforward. Here I have an example in which I am computing the factorial of a number, but it may happen that negative number has been given as input, or very large number has been given as input of factorial, and then at the runtime it may happen that we have to, then it will raise some kind of exception and the application will just halt. So we can use some kind of constant expression there. You can know more about it. Uh, it is like inline functions only, but in terms of inline functions, what we do is that we expand the code at the compile time, right? But instead in constant expression, we just compute the value of the functions or the variables as well. And constant expression are very powerful. They can be also used in the constructors of the classes. So variables can be initialized with constant expression. Functions can be used as constant. So I'm just checking here whether it is computed while computing the factorial. I just check whether if it can throw some kind of exception at runtime. And yeah, and then just checking this, if it is less than 0 or greater than 15, then just throw this error, and otherwise just compute it. So the beauty of this is that you may say that this is runtime error only, but this code will not even compile if you will just change here the input as 10 to -5 or greater than 15 value, that is like suppose 30, then this code is not going to compile it. That is another thing. Uh, One very important thing that I observed was that you can use hash maps and hash sets wherever we can, instead of maps and sets, because the implementation is completely different. Uh, a set or a map is actually a self-balancing BST, like a red-black tree, and the operations like search, insert, and delete are uh, log n. But an unordered set or unordered map that we say in C++ is actually a hash map. And when it is a hash map, all of these things are just one in the average list. So, and the implementation is always a hash table. Only thing that you will lose on is the ordering part. that's okay, right? Whenever, as I said, like wherever possible, just that use. But because of that, the search time, insertion time, and delete time, deletion time will be increased drastically from log n to log 1. So another thing that I have for you is to use range-based for loop. You would have heard a lot from people about this, and like even I also opt for the view that I should use, but I was not using it initially because of the fact that I was thinking that it may impose some kind of overhead at runtime, right? We are using a smaller syntax, and then it has to find like what is the length of the element and how much it has to uh, uh, iterate through, and this can like uh, put some kind of overhead at runtime actually. So I was not using it, but recently I came to know that no, this is all thing, everything. The loop gets expanded at the compile time only, so there is no issues there. Like the code on the upper side, as you can see, is a example of a map, iteration through a map, and it is very simple code. If you can see, otherwise we have to use iterators and we have to check whether it is ending or not, and then you have to. If you are not using auto, then you have to also create a kind of iterator for map, and this code will be like will be looking cumbersome. Uh, so with range-based for loop, it is looking very short and sweet, right? Very straightforward. And I tried to just expand it, this code, like how the compiler sees it, uh, actually, after expanding it in some of the phases during compilation. So there is a nice website like CppInsights.io that will give you how the compiler will see your code during the expansion of it. There is a phase in compilation. They explain you this. So how this code gets expanded is that some kind of begin and an iterators are getting created, and then uh, we check whether the begin and end iterators are equal or not, and then we just keep on moving the begin operator, similar to what we used to do. Yeah. And here is that we are identifying the element there, and then we just print it out in the for loop. Right? Yes. So, and one more thing, small tip that I've heard, I have not used it for custom objects. Like here, we are using STD map and using range-based for loop on a STD map. So that is like working fine, but I've read somewhere that for using your custom classes, you have to supply the begin and end operators in your code via some kind of function or as a member function of that class itself, and only then you will be able to use range-based form. So just see to it. And if you get some error, it's not an issue. You can use range-based for loop for your custom objects as well, but just that you have to give begin and end operators. Yeah, begin and end iterators. Sorry. Yeah. So that is all. One tip that just came to my mind while the first presenter was presenting was that, and I just added it to the slide. That this is my thinking, that think of your code that it will be seen by many other developers to develop many different functionalities. So always keep this in mind. So you will be writing very clean, robust code, and as it will be seen by many other developers, so you will try to maintain good variable names. So that's all from my side.